Thanks very much, Chantal, and thank you all for coming this afternoon. As Chantal said, my research is in microbial genetics, and so this is kind of a neutral topic, but I wanted to share some of my thoughts and experiences with regard to these issues, the zero-emission vehicles and impact on climate change. Some of you may have seen our electric vehicle downstairs, the Mercedes C-Class, and several of you have stopped me in the hallway and asked me about it. So I thought that I would just make a presentation so that we could all discuss this, and maybe this can be the beginning of a longer discussion on this important topic. And I also wanted to mention that I know that we're going through strategic planning for the institute. Chantal said it was the institute was called the Center of Marine Biotechnology when I joined 15 years ago. The name is now, of course, broader environmental technology, and I think that it's certainly an important area for us to be knowledgeable about. So actually, I've been reading about and noticing climate change for some time, being at the age that I am. But in 2007, there was an event which piqued my interest further, which was the publication of a cover feature in American Scientist on extreme organisms, which my lab published. However, in that same issue, there was also a report from Sigma Psi on confronting climate change. And it was a very sensible report. It was a committee that was chaired by Peter Raven, and it said things like, we need to avoid the unmanageable. We never want to get to a place that's unmanageable, and we need to manage the unavoidable. We want to integrate adaptation and mitigation. And then they also had a roadmap. And in the roadmap, one of the points that I noticed is that they wanted to have increased efficiency for transportation. And I thought that this was an area where I could make a personal contribution and commitment. That's kind of what sent me in the direction of the electric vehicle. So my talk today is going to be divided into four topics. Initially, I want to start with a historical perspective on transportation, on automobiles. And this will be a very, very general presentation, so please feel free to interject. Then I'm going to go into a little bit into the climate change issue. And in particular, I'm going to talk about some of the United Nations predictions and some of the reality of climate change that we're experiencing even this past summer. And then I'll talk a little bit more about the current electric vehicles that are available, the batteries that they use, and the electricity generation that is currently being currently prevalent, not just in this country, but all over the world. And then finally, I'll finish with sort of a future perspective on zero-emission vehicles. So another book that I recently read was written by Tony Seba, and it's called Clean Disruption, Energy and Transportation. This was published in 2014. And in that book, being an economist, he talks about disruptive forces in history. And in particular, he shows these two pictures, this one from 1900, the Easter Parade in New York City. And you can see, I think you can see that essentially all the vehicles there are horse-drawn carriages, except for one. And there's one automobile. Okay. So in 1900, essentially everybody used horse-drawn carriages. And here's the same event 13 years later. And you can see that there's been a disruptive change or a radical change. And I don't know whether, is there any horse-drawn carriage? Can anyone see one? I don't know whether exactly the horse-drawn carriage is behind the other automobile, but I think there's maybe one left. So within a matter of 12 or 13 years, the vehicles that were used for transportation, at least in New York City, had changed. Now, fast forward 100 years. This is a picture from Oslo, Norway, where electric vehicles are, if not the majority, pretty close to it. And so are we going through another disruptive change in transportation now? And so that's the topic that I would like to address. So actually, the history of electric vehicles is really quite lengthy, and they were originally developed in the middle of the 1800s and 19th century. And in fact, at the turn of the last century, electric vehicles actually represented a larger number of automobiles than gas-powered vehicles. So there were about 38% electric vehicles and about 22% gas. And some of the reasons for this was that they were simpler. They just required a simple motor with a few moving parts. They were quiet and smooth to drive, and they were very easy to start. Those of you who know about old gasoline-powered vehicles know that they actually required a crank start. So you actually go out there and turn the crank in order to get the engine to turn over, and that's where the term turnover comes from. And the range, even in those days, wasn't too bad. Here's an article from the New York Times, 1906. Electric car record makes a 100-mile run. And it apparently killed a dog on the journey as well, unfortunately. And it ran this 100 miles on a single charge. And it went at 14 miles per hour. So, of course, the roads in 1906 aren't the roads of today. So that's a pretty impressive feat even back then. However, we all know that electric vehicles in the early part of the 20th century lost out to gasoline vehicles or ICE, internal combustion engine cars. So what really happened? Well, they were both readily available in the early part of the 20th century. But by 1916, something electric happened to the gasoline-powered cars, and that was ignition. A battery could then be used to turn the motor, turn the engine, and start the car. And that was the single most important improvement to the gasoline car that allowed it to beat out the electric vehicle. So no longer did people have to go out and actually turn the crank. They could just sit in the car, turn their key, and start. Of course, there was the other reason why people preferred gasoline-powered cars, and that's fuel cost. So back in the early part of the 20th century, it was about 5 cents a gallon for gas. And for electricity, it was about 20 cents per kilowatt hour. So it turns out that cost of electricity in the last 100 years has actually gone down. We usually pay about 12 cents a kilowatt hour. And you all know what you pay for gasoline. It all depends on whatever is going on. We were paying over $3 not too long ago. So probably partly as a result of the low cost of gasoline, gas distribution networks were greatly expanded into the rural areas so people could actually go distances. Whereas the electric infrastructure was pretty much restricted to the cities where it was cost effective to put the power lines. So if you're interested in this topic, I would, there are a number of books I would encourage you to look at. This one called Car Wars, The Rise and the Fall and the Resurgence of the Electric Car by John Fialka. It was published last year. So we all know that over the last half century that everybody wanted an automobile and everybody wanted a car. So at the moment, there are over 1 billion cars on a planet that has 7.4 billion people. And the other 6.4 billion people who don't have cars all want cars. So it's likely that that number is going to grow. Now, this looks like a very smooth curve the way I've drawn it here, but in fact, there have been a few hiccups along the way. And if you look at it in terms of oil consumption, this is what it looked like. So the increase in oil consumption was pretty smooth up to about 1973. And in 1973, there was a major hiccup. And there are a few of us in this room who will remember those events from 1973. It was an oil embargo. Okay? And this was based on Middle Eastern politics, believe it or not. It was an issue back that long ago as well. And so most of our oil, or a fairly large fraction of our oil, was coming from the Middle East, and there was an embargo. And so all of a sudden, the price of gas went way up, the supply went way down, and you had people standing in line to fill up gas. And that was even true for people who wanted to mow their lawn. So that brought people back to earth and made economists think about the price of oil, and made petroleum scientists think about how much oil was actually present. At that time, the consumption was around 20 billion barrels per year. Currently, it's around 30 billion barrels per year. And so there were predictions about how much oil was actually in the ground, how much could be recovered. So in 1975, a pretty reasonable estimate was there was about 700 billion barrels of oil that could be recoverable in the earth. So that would last at that rate of about 35 years. Well, 35 years from 1975 is 2010. So there was some consternation when this type of calculation was done, even back then, because time does pass. Well, it turns out that by 2005, the U.S. Department of Energy predicted that there's still 1.65 trillion barrels. And at the current rate of consumption, that's another 55 years. So that would take us through the mid-century, and even a little beyond that. And in fact, if you hunt around, there are other predictions. Like last summer, there was an article in the Forbes magazine, how much oil does the world have left? And in this case, the prediction is 2 to 5 trillion barrels of oil. So maybe several centuries. So maybe we won't run out of oil after all. Maybe we can use gasoline-powered cars for the next 1,000 years. Who knows? But there was this other problem that was also recognized with gasoline and petroleum products, and that's an environmental one. And in particular, people noticed that there's noise, smog, toxic emissions, carcinogens. So these were recognized way back, even in the early part of the 20th century, certainly by the middle part of the 20th century. And in particular, people were concerned about carbon monoxide, hydrocarbons, many of which are carcinogenic, sulfur and nitrogen oxides. And there were a number of governmental responses. So, for instance, we passed the Clean Air Act in 1970 and 1990, and that targeted acid rain, air pollution, toxic emissions, and in particular, it mandated reduction in hydrocarbon emissions. And so in 1975, the cars were limited to 3.1 grams per mile, ppm, of hydrocarbons. By 2004, that number was reduced to 0.07 grams per mile. So in this 30 years or so, there was a substantial reduction in the pollutants that were allowed to be expelled from burning of gasoline. And then there was also the CAFE standards to improve the average fuel economy. So there was a lot of steps taken to limit the damage to the environment from gasoline-powered cars. Yeah. Well, it's more than the catalytic converter. It's the actual combustion of the gasoline was much cleaner. It took lead out. There were a very large number of steps that were taken. And the more I researched for this presentation, the more I thought that this really should be a course rather than just a lecture, because it is such a complex series of things. So whether you look at in chemistry or atmospheric chemistry or environmental, the legal aspects of it, there are many different perspectives that one can make. But the one point that people didn't really address, at least in the national debate, was the issue of carbon dioxide. Carbon dioxide is a greenhouse gas, everyone knew that, but it is also a gas that we exhale, and it's a part of our normal composition of our atmosphere. However, the United Nations formed this intergovernmental panel on climate change, the IPCC, and they've come out with a number of reports. The first one was in 1990, the latest one, the fifth one, was in 2013. And even in 1990, this is what they wrote. They said, we are certain of the following. There is a natural greenhouse effect which already keeps the Earth warmer than it would otherwise be. So everybody knew that. Without that, Earth would be freezing cold and couldn't really live there. So it's very important for life. But emissions resulting from human activities are substantially increasing the atmospheric concentration of greenhouse gases, carbon dioxide, methane, CFCs, and nitrous oxide. These increases will enhance the greenhouse effect, resulting on average in additional warming of the Earth's surface. And interestingly, they also go on to say that the main greenhouse gas water vapor will increase in response to global warming further. This was a very interesting observation. And so now, to connect it to the electric vehicle story, so are greenhouse gases something that can be reduced through the use of electric vehicles? Well, currently electric vehicles constitute less than 1% of the automobiles that are used. And so if you think about it from the current status, transportation accounts for about 1/3 of the U.S. energy use and about a similar percentage of greenhouse gas emissions. And of the greenhouse gases on the left here, carbon dioxide is about 80%. So if electric vehicles could be made to run without increasing carbon emissions or decreasing carbon emissions, I should say, then they could make an impact on this. So meanwhile, while we were having this debate since 1990, people were still driving gas cars, and carbon dioxide was still being released, and carbon dioxide levels continue to go up. And so this is in the pre-industrial era, the carbon dioxide concentration was below 300 ppm, between about 200 and 300. So by 1960, it had gone up about above 300 ppm. And just last year, it went up about 400. And just the back of the envelope calculation, just from this, is over the last 12 years, there's been about a 25 ppm. So if you extrapolate for the next 100 years, that would be about 200 ppm. So we increase the CO2 content of the atmosphere by about 50%. Well, there are some very smart people who are doing this type of analysis, and not just on the back of the envelope. And in particular, the IPCC has made a projection, a series of projections called representative concentration pathways. And this is looking at radiated forcing, which is in watts per meter squared. So it's basically looking at how much heat is going to be absorbed. And so they have different scenarios. And this is over the next 100 years. And if you look at this, the highest emission pathway, which is pretty much what we're doing right now, business as usual, is going to result in and in this case, it's CO2 equivalent, it's not just carbon dioxide, but some of the other greenhouse gases that we're talking about. It's going to be above 1,000 ppm by the end of the century. Now, if you were to put on the brakes immediately, then the best case scenario would be that red line, which is the RCP around 2.6. And in that case, the greenhouse gases would go up, CO2 concentration would go up a little bit, about the middle of the century, and then it would come back. So what would happen in terms of the temperatures that we would face? So if you look at the projections from recent averages, 1986 2005, the low emission scenario would limit the increase to about 1 degree Celsius. But this business as usual would result in a 2 degree increase by the middle of the century and about a 4 degree increase by the middle of the century. So what does that mean in terms of the planet? Okay, so the temperatures are likely to increase unless we do something immediately, which I don't see really happening at the moment. Temperatures probably increase 2 to 4 to 5 degrees, something like that, depending on who you're at. Well, the polar ice caps will melt by the middle of the 21st century. And in fact, the Arctic is already melting and has melted summer. Probably in the next 2 decades, there won't be any polar ice cap summer. Ocean acidification. Most of the CO2 on Earth is actually dissolved in the ocean, probably 40 times as much in the ocean as in the atmosphere. That more CO2 that goes into the ocean, the more acidic it is. That's going to be felt again mostly in the polar region. There's going to be a lot of changes in the precipitation, resulting in desertification in places, and stronger tropical storms. And perhaps the most concerning is that there's going to be a reduction of agricultural yields in temperate and tropical regions. There may be an increase in the higher latitudes, but in the regions where most people live, there's going to be a reduction just from the temperature. And the world population is predicted to increase from 7.4 billion to 11 plus billion. Now, I can remember 1966 when it was 3.5 billion people, 3.5 billion. So during my lifetime, it's tripled or quadrupled. Now, there was also a report that was issued here in Maryland. It was Maryland's Scientific and Technical Working Group, Maryland Climate Change Commission. And they issued a report also in 2013. And there was an article in the Washington Post which showed the different scenarios again, very similar to the scenario we got in DC. And they sort of dealt with it. They changed it from meters to feet, but they had 4 different scenarios. The historic rate is go up about 2 feet. Mitigation, significant efforts would be 4 feet. Business as usual with no significant efforts, 6 feet. Or the worst case scenario, melting of all the ice caps of the 8. So what does that mean in terms of where we are? Okay, and so there is this online tool, at NOAA, that actually shows you what the effect of sea level rise would be. SLR, sea level rise. So if it went up 2 feet, it's not too bad. I think you guys know this is the longest of the field. And 10th Street, is that 10th Street or Thames Street? Thames. Well, at this point, it's one of the streets right down by the harbor. So that doesn't look too bad. Okay, so this is 3 feet. That's 4 feet. The 4 feet, you can see that the aquarium area is under, and you can also see that the Thames Street is flooded. And that's 6 feet, it comes up to our building. So now that, maybe you can put some walls up in storm surge might be a few feet more. So that doesn't look very good then. And in fact, when Hurricane Isabel hit in 2003, this is the way I think it was Pratt's look. And actually, I had a student who was defending his thesis a couple of days after this. That one of his big members flying in from Massachusetts, and he was quite concerned that he would not be able to defend his thesis. But this is a good 13 years ago. There was an article recently in the Washington Post predicting how many homes would be underwater by the year 2100. And you can see that the number is over 1 million homes nationally, and including, I guess, Florida is the most vulnerable. Maryland, with 3,000 miles of coast, 65,000 homes. So it would have a pretty serious consequence, although this would be unfolding over time. The question is how much time? So this is the average temperature anomaly over the last 140 years or so. And you can see that most of the warm years have been in the 21st century. And in fact, if you look at the very top one, 2016, that's this year. So this year has been the hottest on record. But then again, last year was the hottest on record. The year before that was the hottest on record. So what I'm concerned about is whether maybe the climate models are being a little bit too conservative. But it could very well be the other opposite. But, right now, the Earth has warmed about 1.5 degrees Fahrenheit since the pre-industrial period. And so we could warm maybe another 2 to 4 or 5 degrees for the next century. So where does that fit in sort of the geological time scale? Well, we know that there are periodic ice ages, and possible that we were actually heading toward an ice age about 12,000 years, all of human history. So most of human history is since the last glacial period. And in fact, it looked like those temperatures were fairly moderate, fairly high, and then moderated, and then going down. And then suddenly, in industrial time, this and then the question comes, is the global warming that we're seeing directly related to the carbon dioxide levels? And that's a very important question to answer. If you talk to geologists, and if you look at the paleontological records, there's a pretty good correlation. In fact, a tremendously scary correlation in the sense that you see the temperature and the CO2 is a very strict correlation, and that's not just over 10,000 years, this is over almost 500 million. And if you notice, the CO2 concentration has never been above 200. This is kind of, in my mind, letting the genie out of the bottle. You're going to have to try to put the genie back in. You want to return back to the way it was. So this is not a question to be taken lightly. So the question I really want to address here is, can we limit carbon emissions using electric vehicles, such as hybrids and plug-ins, battery-operated EVs? So there's these acronyms. The PHEV is the plug-in hybrid. The BEVs are the battery. And so I just want to talk about a few of the vehicles that have been introduced in the past, or in the very recent past, or possibly in the future as well. So let's just talk a little bit about the GM EV1, the Toyota Prius, which of course is the first gas-electric hybrid. Briefly about the Tesla Roadster, the Chevy Volt, and the Nissan Leaf, the Tesla Model S, and maybe talk a little bit about the future cars that are due out. So in the 20th century, there was really only a single electric vehicle that was made commercially, and that was made by General Motors. It's called the EV1, and it was sold. It wasn't really sold; it was only leased from 1996 to 1999. And there were about 1,000 of these, 1,100 made, and they were a two-seater car. It was a two-seater car that had 80-mile range, took about 4 hours to charge, and actually that's pretty similar to the specs on many of the current. However, in 2003, GM ended all of the leases, took all of the cars back, and destroyed all of them. And there's actually a movie called Who Killed the Electric Car? You might want to see that. It's actually a fairly balanced, in my opinion, balanced view of it. Who was the narrator for that? Gene. It's really quite well done. Okay, so a true battery-operated electric vehicle that first appeared commercially was the Tesla Roadster. It came around 2003 or so, and I think 2008 was when we really get a hold of one. These were pretty expensive little sports cars, again, a two-seater. There are about 2,200 of these on the road, and they can go 0 to 60 in 3.5 seconds or something like that. I haven't driven one. The more common electric vehicles are the Toyota Prius, Nissan Leaf, the Chevy Volt, and the Tesla Model S. And as you can see, most of them have only sold around 100,000 or so. All of these are using the lithium-ion battery. They seem to be pretty much the standard. So I'm not going to say too much about batteries, but obviously there's some desirable characteristics in batteries that have a higher power capacity. Pretty much what this plot is showing is the power that's plot per kilogram versus the specific energy watt-hours per kilogram. You want a fast charge rate, a low discharge rate. You want a long life expectancy. Many rounds of charge. And you can see for the EV1, and using that battery, you might be using it for starting a car. And the lithium-ion batteries, which are pretty much what we use in all of our gadgets. There's a pretty significant difference. The lead-acid batteries are cheaper, but for instance, the EV1 has about 1,200 pounds battery. So if you wanted to have a lithium-ion battery of the same magnitude, than 1/4 the weight. So very recently there was an article in the Business Insider on the newest EVs, and all of the companies are coming out with these vehicles now. There's Ford Focus, the BMW i3, the Volkswagen e-Golf, the Fiat 500 Fiat Soul, and the Mercedes E-Class, the e-Drive, Nissan Leaf, and then there are several new ones that are coming out, the Chevy Volt, the Tesla Model 3, the other two Tesla models are all laid out. You can sort of see here that there's kind of a division here. There are those that go more than 200 miles, that range of around 75 to 100 miles. So these cars are pretty good for commuting. If you want to go long distance, you have something that will have a larger range. So that's one of the goals of the design at this point. If you look at the sales of EVs, they're doing pretty well. You can see again the Volt, the Leaf, the Prius, and the Model S Tesla are the primary ones that have been sold over the last 5 or 6 years. But there are all these other cars that are on the market. The question is, how much higher will that go? If you look globally, the United States is not the only market, and you can see actually the market in China is growing quite substantially compared to the United States. Western Europe as well is growing quite a lot, and Canada. So there is a significant growth in the sales of these vehicles. So can these vehicles really make a difference to the carbon emission? So I wanted to actually show you, and there's a lot of different information out there, and this is just one of them, but I think it's sort of typical. So if you look at the effect of driving on carbon emissions, a large car that gets 15 miles per gallon may be spewing out 500 grams of CO2, half a kilogram every kilometer. Remember, there are a billion cars in the planet. A medium car might be only 300 or so. A small car may be 200. And a hybrid car, like a Toyota Prius, would be 190. So that would be a significant improvement. Of course, motorbikes and scooters would be even less. But an electric car that's run on renewable energy would only be 69 grams per kilometer. And this includes not just the direct emissions, but also the fuel production and the vehicle construction. This is frequently something that people mention about, because otherwise this would be zero. This was just running on solar power, wind power, zero. But it's not zero because of the fuel that we produce, at least at the present time. If you're driving an electric car using coal energy, such as in West Virginia, I'll show you in a minute, almost all of the energy is produced, almost all of the energy is coal, you might as well drive a hybrid car. So this is what really is an important point. If you look at the electricity production worldwide, it's pretty much an average of about 2/3 fossil fuel and 1/3 non-carbon based. So in this case, this would be primarily hydroelectric. And then if you look at specific countries, you can see that there's quite a lot of difference. One thing that occurs to me in looking at this is there are two giants in electricity: China and the United States. The United States may be kind of not growing very significantly in terms of population. China, however, even if the population isn't growing, that's actually 4 times larger population. So if they're going to bring their standards and start that is going to increase by a factor. And you can see the ground here is coal. So most of their electricity is coal. Although they do have a lot of hydroelectric. In the case of the United States, there's a fair amount of gas. We can look at this in a little bit more detail at another slide. So the electricity production in the United States is about 1/3 from coal, 1/3 from natural gas, and 1/3 from non-carbon sources. But there's quite a lot of difference depending on where you live. And I wanted to share with you this online tool that the Department of Energy has, considering the variability in the source of electricity from state to state. So this pie chart shows the source of the electricity in different states. So this is from Maryland. And on the right-hand side, you can see pounds of CO2 annual emission per vehicle. So down here at the national average, and you can see that it's actually not that different in terms of it's about just below 5,000 pounds of CO2 per all-electric car, as opposed to like 10, 12,000 pounds per gasoline car. So in Maryland here, where we have some nuclear, quite a bit of nuclear energy, but we also have a lot of coal. Whereas in the United States as a whole, there's more gas and a little bit less nuclear. Where do they have a better source of electricity from the standpoint of carbon emissions? Well, California is a little bit better, primarily because they're using gas, that's 60% gas. So you can see that it's only about 2,500 pounds of CO2. Oregon is even better. They have a lot of hydroelectric power, and it's under 2K. And Washington State is even better. They have more hydroelectric. West Virginia, as I mentioned earlier, 95% coal. So there's no advantage in driving an all-electric vehicle in West Virginia. In fact, you'd be better off with a hybrid there. In our nation's capital, it's all from gas. I wonder if that has any possible. In the Northeast, there's a lot of nuclear power. So, for instance, New Hampshire, almost 50% nuclear, and it has a lower percentage there. Vermont, none at all, because it's all nuclear, hydro, biomass, and wind. It's the only state where you can drive an electric vehicle and feel that you're not contributing at all to it. Maine is also pretty good. I think it's a lot of biomass. Anyway, I suggest that you go to this website if you're interested in finding it. There's also this website, Union of Concerned Scientists, where you can actually plug in your vehicle and it will tell you how many grams CO2 equivalent from another. But basically, a gasoline only is going to be more than double that of a fully electric, and at least 40% more than from a hybrid. So I think one can conclude that driving an all-electric or a plug-in electric or even a hybrid is going to have a positive benefit from the standpoint of the carbon emissions that it generates. And in the future, that actually the EPA has handed over our future to the California Air Resources CARB, which runs the zero emission vehicle program, the ZEV program. And it's very complicated, too complicated for me to explain. But in its early days, it was really quite simple. It said 2% of the sales of zero emission vehicles by 1998 in California. The idea is that California is test case and that California does 10% that's by 2000. But by 1996 to 1998, the price was dropping. And then they instituted these partial ZEVs. So for hybrids, because at that time in 1990 they didn't anticipate the Prius. So they had credits allowed for different hybrid vehicles. And then in 2001, there were 3 new vehicle categories introduced. In 2003, an even more complex set of categories. I like to go to this picture because, you know, this is what's happening at present, but in future, it's simpler, at least this is, of course, a projection, something already changed. But you're talking about somewhere from 5 to 20 to 25% by 2025 vehicles should be there are a lot of other states that are following California's program, including Maryland. So there are Connecticut, Maine, Maryland, New Jersey, New York, Oregon, Rhode Island, and the three other states, Washington, Delaware, that follow part of it, but not the entire thing. So what about worldwide? What does it look like? Well, this shows both on the right-hand side the percentage of vehicles in 2015 over EVs, and on the left here, the total number of cars. So you can see that China and the United States again are the big dominant players in the market. China seems to be going up. The United States in 2015 hit a plateau. We're hoping that will go up in the future. The percentage here is not much different. It's barely 1%. However, there are smaller countries that have made a much stronger commitment. The Netherlands and Norway in particular. So you can see that the Netherlands is already 10%. Norway is above 20%. And both of these countries have announced that by 2025 that they will go to 100% electric vehicle purchase. Of course, the value of this from the carbon emission standpoint is dependent on the electricity generation. And there are a lot of countries, especially in Europe, Scandinavia, that have made a much stronger commitment to carbon-free energy. So, for instance, Iceland, Switzerland, Norway, Sweden have essentially 100% carbon-free electricity. Much of this is from hydroelectric, some of it's from nuclear, and in the case of Iceland, a lot of geothermal. However, there are some interesting other points here. Denmark, for instance, has a large green that's wind. Really a third of more of its electricity comes from wind. That's exposure there. Ireland also has a very large amount of wind. Here's the United States down here. Two-thirds of it is fossil fuel. However, in the United States, we do have energy deregulation. So you may not be familiar with this, but if you're not, I recommend that you go to this website to find this. So in the past, we had no choice. We had power plants, we had a utility, local company that was buying these power plants. Well, now, local electric companies can offer electricity from many different suppliers. It's not just three. In the case of Maryland, there are many others. So you can get supplies of electricity that's fully renewable. And that's what Power mentioned at the outset, that you actually purchase electricity at home from fully renewable wind power. And that's something that we do in the field. What this allows for us to purchase at more or less market rates. We pay 10 cents per kilowatt hour. Better than wind power. And so when you drive in an RV, even though the online tools say a certain number of equivalents, we actually are not using it. It's only when we charge up downstairs subject to that. So, in summary, I just want to say that the characteristics of the electric vehicle versus internal combustion car are quite different. The efficiency of an electric motor, 90% plus. Even with the 100 years of evolution of the combustion engine, no way that the IC can ever compete with the principal. Simplicity. Electric vehicle, electric motor has only about 20 moving parts. So it doesn't have most of the mechanical requirements that are very complex modern gasoline. Carbon emissions, you're just using the standard Maryland electricity. It's less than 1/2 the amount of carbon. And fuel cost is also about 1/5. The one thing that you do give up on is range, although that is also starting to change with the new generation. So, for instance, the technology marches on. The progressively longer range cars, for instance, the other day, Tesla announced the E100D, which got $150,000. And it's using the same batteries. Batteries are slightly higher, they're just packed with slightly higher density. This is the weight slightly. But of course, Tesla and other companies, especially in China, are building gigafactories. You've probably seen the pictures from the Nevada desert. It's the second largest building in the world. I guess the largest building is owned by Boeing. But they are more than likely going to be decreasing the cost of batteries. So even if you don't have a tremendous improvement in the technology, the lithium-ion batteries currently, General Motors is 145 kilowatt-hours per volt, which has a 60 kilowatt-hour battery. So the batteries are not really that expensive at $8,000. But it's likely when you go to these larger factories, there will be a reduction of the capacity. So you can then have in 100. This is a 100 kilowatt-hour battery. There's also an increasing number of charging stations. There are about 2 million worldwide. Tesla has been at the forefront of installing charging stations for use by their cars. So this is a car company that's also a fuel. There are also a number of wireless EV charging systems, and this is particularly useful for buses, which circulate in a fair way. But you can also get these from the garage. You don't want to plug it in. You can drive over it. And then, of course, there are things of autonomous parking and driving capabilities. I'm sure that you guys have read about and so it won't be long before it's likely that the electric vehicles will be the ones that are testing this capabilities first. And then Tesla is already doing that with the Model S. So you can just sort of sit back and watch a movie. So that's pretty much it. I thank you for your attention. I just want to conclude by saying that I think that EV use does slow down carbon dioxide emissions, and as a result, the rate of climate change. In the United States, 2/3 of the electricity is still from fossil fuels, although there are some states, Washington, Oregon, Maine, Vermont, and New Hampshire, that have a large fraction of carbon-free electricity. And California and CARB is leading the legislation for mandating the ZEP standard, and there are many states that are following, including Maryland. Norway and Netherlands have the highest EV adoption rates, 10 to 25%, and they're planning to achieve 100% by 2025. And there are some countries in Scandinavia, Switzerland, France that have nearly 100% carbon-free electricity. Okay. And so I think that the ultimate impact of electric vehicles on climate change will depend on the rate at whole world moves toward So I hope I've given you some things to think about. I would love for there to be a continued discussion on this. Not intended, it's not my area of research. But this is my sort of more personal passion. I appreciate the opportunity to present this to you. If we can continue this discussion in some way, I would welcome. Thank you very much.